Will Stott, that's S-T-O-T-T.
Alex Ives.
Jordan Engel, and we're all from Omaha North High School.
Okay. Omaha, Nebraska. That's where we're from. So.
Great. And what is it that you've made here? You have these briquettes here that don't look like what you'd find in the store.
No.
Well, these briquettes are actually a pressed mixture of wood, eucalyptus leaves, mango leaves. There's a puntia cactus ground up in those, which is a pretty invasive weed in Madagascar. They're mostly wood though, ground up wood. There's a little bit of sawdust mixed in with them. They're mixed with water, and then they're pressed in our press right here. They're pressed in that cylindrical shape. And when they come out, they're dried for about 3 days, and that's what they look like after that process is over.
And so, does this come up?
Yes, it does.
Utilize it. It uses mechanical advantage. The original designs for the system call for a hydraulic press, but we designed.
Those are a little hard to find in
exactly.
a lot of communities.
Exactly, and if they broke down, there would not be anything going on.
Okay.
So we want to develop a system that the locals that we could make in Madagascar.
Yep.
So what we can do here is lift this up and then drop it to press it.
Okay.
And then this adjusts so that we can lower it down, and we can keep pressing it out and.
And that presses out all the moisture?
Yep.
And compresses all the material that's inside it?
Yep. Presses it down into that briquette shape. And
we have a PVC pipe in the middle.
It looks like it's all kinds of drilled out.
Yeah, it is. So that when the briquette, basically, when we have a mixture of ground up stuff, we'll mix it with water to make a slurry.
Yep.
And we'll pour it into there. And then when we press it, we'll push all the moisture in through here.
And then that can drain out.
Out through this hole in the steel plate right here, and then it can be used as water in later briquette mixtures. It's water reclamation. As we know, water is a pretty valuable resource in third world countries.
Okay.
So then, once we press out all the water, we can remove this plate and then set this on its lowest setting and actually just push the briquette right out.
Okay.
So.
And then do you then need to separate them into individual pieces, or?
If we make them this high, yes. We typically want them about 4 inches long.
So then you'd saw them or something once they dried?
Washers between them, gigantic washers.
Okay.
We don't have any with us up here. There's
just put some kind of release mechanism in between each one. Okay. And where'd you get the idea to do this project? It sounds like a pretty well thought out project.
Our amazing mentors, Susie McGuire and Dr. Ed Lewis, at one point they both worked at the zoo, and the Omaha Henry Doorly Zoo is actually working in Madagascar right now. So Susie and Ed brought the idea to us, and they asked for our help, and here we are today.
Wow, that's neat. Okay. And are you doing this in school or after school?
Yes, this project was actually based out of one of our classes. We have an engineering course that all of us were involved in at school, and that's where this project came from.
Wow, that's great. And do you think you can run this out to the rest of the world and have people try it? Do you think it's ready for that?
Well, it's actually being tested right now. There are rocket stoves being tested right now in Madagascar, and so we're already in the process of implementation.
Wow, that's great. And so, how does the stove work? The stove is not your design. The briquette is, correct? Or have you redesigned?
It is modified to be our design, but we want to improve as much as we can.
Yeah.
So the rocket stove, we want to make these as cheap as possible. So all this is just a popcorn tin with this 24-gauge stovepipe chimney inside. And all you have to do to operate it is just load a briquette in and light it from the inside. And then the heat is going to be sucked up through the center of the briquette, and the flame will be sucked out. And then one of the modifications we made, that we created, was this lip on the end, and what that's going to do is it's going to force the cyclone of hot air that's going to create. It's going to force it back down so that it burns for even longer, and it's going to virtually incinerate any of the briquette that's in there and more of the emissions, so that there's even less emissions coming out.
Then when you need more fuel, you just stuff another briquette in?
Yep, exactly.
An interesting spec that we like to throw out when we're talking about our rocket stoves is the average wood fire, a very, very hot wood fire, would be around 600 to 700 degrees, and that'd be a really hot fire one you don't want to stand too close to. This, using only wood and leaves and such, these rocket stoves burn at an excess of 2,300 degrees. We're not exactly sure what the temperature is because we used our our testers, our thermostats from the physics department at our school up in Burnham Mountain. They go to 2,300 degrees, so it's somewhere far enough above that it burned through the testers. So we're increasing the efficiency of the wood with the shape of our chimney by an enormous amount.
That's great. And what year were you in school?
We all just graduated.
Oh, no kidding. So this is a senior project.
Yep.
And where are you going next?
The University of Nebraska at Lincoln.
University of Nebraska, Omaha.
And then I'll also be at the University of Nebraska in Lincoln.
Okay, great. And how long have you been on this project?
Since August.
Oh, really?
Yes.
So you got the mission in August, and
It's a continuation. There was another group working on it the year before us, August through May then, and but they focused primarily on the rocket stove, and then this
Saving
year,
the lemurs.
yes,
Is the big thing.
yeah.
Okay.
So, and we came and put all this together.
There's a lot of extra stuff in. And
yeah. Well, that's great. Is this part of your project here
Yes.
too?
This is actually the first.
Oh, so this is how you get the material that becomes the
Yes.
briquette.
Exactly.
This is intense.
So so we have 2 chutes up here.
Okay.
And this side chute leads to. I'm just going to show them what's inside of it anyway. The side chute leads to these blades, and so what's going to do is it's going to chop whatever you put in there into smaller chunks. Oh, look, there's a chunk.
Let's be careful.
It's fine. But these we'll cut into smaller chunks and just slice, and these blades are deceptively sharp.
Yeah.
Yeah.
Incredibly. And then once we get smaller chunks out, we can take them and load them through the top one, and then
Chop them even more.
mesh them in these teeth.
That's pretty cool.
And then from there, we'll get a fine material that we can mix with water to make the slurry to press into the briquettes.
Well, that's great.
So this is actually the second model of the grinder. First one, third. The one that we started working with, and then we made about 14 major modifications to it. So, yeah.
Wow, that's great. Well, thank you so much.
Yeah, thank you.
Do you want it spinning?
Oh, and it's a 2-person spin, too?
Yes. Why it's squeaky today.
And once you get going, it'll just go by itself.
Oh, because it has enough weight as a flywheel.
We're gonna add it. Something definitely similar to this.
How much does it weigh? Like 385? Oh.
About 400 pounds.
Yeah. So we've also been toying around with the idea of adding a flywheel and like a bicycle mechanism. Just to make it easier.
Great.
Yeah.
Wow, this is very cool. Thank you.
Yeah.
Thank you. We also came through coming over as well.